laws of indices. A to the power of m times A to the power of n is equal to A to the power of m plus n. Law number 2 of indices. A to the power of m divided by A to the power of n will be equal to A to the power of m minus n. A different form of A to the power of m divided by A to the power of n can also be set in the exams like this, like so. A to the power of m, everything over A to the power of n. The answer is also the very same one, which is A to the power of m minus n. Number 3, law of indices. A to the power of 0 is not 0, is not A, but is equal to 1. Law of indices number 4 is A to the power of m, as you see here. Before that, there's an open curve bracket. After the m, there's a closed curve bracket, and there's a power just beside that, another one that is n. This one is whatever you see by taking away the left curve bracket and the right curve bracket. So take away the left curve bracket, we have A, capital A, the base. Then we have the power there, little m. Then take away the right curve bracket, we have the n, but don't put far away, bring near. It means multiply, times, if numbers are involved. Then we have law number 5 of indices. A to the power of 1 over n. This is very, very easy. Just write back the A. The base, to help you remember, there's a 1 over. This over you put above the A. The over. Then you go parallel to A. If it's a 7, there's no parallelity. Right, and then you open the V-shaped stuff and bring this n carefully into that region there. Into, I emphasize, yeah. This should be a straight line, not curve. Inside there. Never ever put on that line there or outside there. Number 6. Law number 6 of indices is the very same, which is A which is the very same. For the time being, I will only consider the over n. There's something up here. Okay, there's something up here. I'll come back to that afterwards, or to help you remember, I will stick back to the 1. Afterwards, I'll change a little bit. This one has 2 variations. Similar to number 2. One is left hand side, right hand side. One is numerator, denominator, upstairs, downstairs. Here is a different variation. So I am going to change this m here afterwards. So the 1 will become m. So hold on first, we handle with 1 first. Well, 1 times m is m times 1 is m. So both ways we can do it. This one, the same answer must come back. So you write back the A. And for this one also you write back the A. Same. And then here is 1 over. I told you just now, the over, you put an over there and put an over here. There you go parallel if there's a parallel line. If not, never mind. So you go parallel. Then open a V shape. Not too small, not too big, just enough to bring in the n as you see above in number 5. Put it inside. Once again, do not put it outside here or even very much outside. Do not put outside here or on this thing here. Must be inside. And then now I will want you to put a bracket for the right hand side only. The left hand side No need. To make it very clear, I will get the help of the pink color, and now I'm going to put M. M times 1 is M, 1 times M is also M. And that M you put outside here. Like that. Very straightforward. And that M you come and place beautifully just to the right of the M there, as shown now. You will be 100% correct on the left and also on the right. So, since M has come here, this over must cover it. So it's 100% correct. Next one, we are going to the green one, okay? Why not I use here? This is what I told you. There will be the pink color, the yellow color, the blue color. I said something here which has the minus. Then after that, the left hand side blue and the right hand side green. The answers are the same except that you take care of the minus part. So I would want to put that number 7 here, but in green. Law number 7. And what is that? It is A to the power of N. And what's the difference that comes into the story? A minus. That's the minus I said. The moment we can take care of this minus, then number 8 will be the same as this with that variation of that minus coming in, what it represents. And number 9 will also be the same as number 6 here and number 6 here. 2 variations. Allow me to show you here. This A in green, capital A, and the power N will go downstairs, meaning will become the denominator for sure. That negative, you see this negative. Just now I told you over, so you put the over, you put the over, you put the over. Here the negative also you help you to remember that it's an wait. To clarify, I need the pink color. Put it all as over. And then I sang a song. The wheels on the bus go round and round, round and round, round and round. The wheels on the bus go round and round, all through the town. Make it vertical, just to help you remember. Once you have gotten this thing, that negative actually represents the 1 over, then everything falls into place. This one will be the same with the 1 over. This one will be the same with the 1 over, meaning A same 1 over N same. So allow me to prepare in advance number 9. Didn't I tell you that the left hand side will be the right hand side? Same, same, same. Anytime and every time same. As far as this level only. Up to this stage only. But then something happens. Something. But then something happens. As I said, something. What is that something? Very clearly, it's this minus. So that's all. A minus comes in. However, we already know that minus actually will be translated to 1 over. So just put a 1 over only. Straight away we put the wheels on the bus. Go round and round, okay? Straight away we put that. Here too, in two places will be the same. Straight away we put this. What's the one that we have to put? We have to put 1 over. Why so? Because the minus already here indicates is 1 over. It can be proven. When we come to proofs, we will take care of that. The fireworks are still going on. It's the 6th day, I believe, of Shawwal, of that Eid ul-Fitr. I saw at the bank yesterday. Yeah, Eid al-Fitr. Then it is also down there is Mubarak, so it's Eid Mubarak. Selamat Hari Raya. See, they're all living in peace, not in pieces. We must go for that always. Then we have already gotten the answer, which is write back the A. The 1 over means put the over or roof above the A, go parallel to the A. Don't go narrow, don't go too wide, just go nice enough for the end to come in and fit in. 100% correct. Here is the same answer. What did we write here? Same, so just write that only. The only difference is a minus. A minus means 1 over, so 1 over whatever we found just now. Some people straight away will put nth root of a to the power of m. But to make it very clear, we do a first. Got that one correct. Then we see the n there. That's the one that's going to give the nth root, to make it very clear. No harm if you do nth root of a to the power of m. But here I'm trying to make it very clear. That is the one. Draw parallel there, don't go too narrow, don't go too wide, just nice enough for that n to come here. We haven't taken care of the m part, yeah? Hold on. Nope, I don't want that color there, I want it here. We haven't taken care of the m part. So hold on while everything falls into place like a beautiful jigsaw puzzle being solved right before our eyes. So the nth root a is there, so I will write the a. We must write the a, and then we will put the over there. The n must come in where? Parallel. We have already learned that it must be somewhere there to fit in the n. The n will come in here, okay? And allow the n to be inside, not outside. Must be inside. And then here we want a bracket, curve bracket close. Here come back in front, curve bracket open. And that m, I won't have to represent it with pink now. Just put the m here. Next to the a, here also next to the a, but assume the bracket is already there, so put it next to the a outside. Here no need to put bracket, not necessary. Now this m is there, so it must pull out. This one, the pink color must pull up, must cover it until where the m is, and then this one must be here. Same thing over here. Is there anything? Yeah, a little bit more there. And that, my dear students, once again, pink color, as I said in the other video, yellow color, blue color, and the green color. This is the thing that you should be very clear about. Why so? Because this is the beginning of the negative power. So it's the beginning of the negative, and the rest will also be negative and negative. So we have to tackle this one. We have to focus. And what is the negative? Is 1 over. Haha, got the secret. Negative 1 over. Negative 1 over. Negative 1 over. Whatever the question there, same answer. Whatever the question is there, the same answer. That is so easy. Okay, follow after sir. We read together at the count of 3. I'll give you a signal first, like this: 1, 2, 3. Then after that we'll start. Yeah. 1, 2, 3. A to the power of m times a to the power of n is equal to a to the power of m plus n. A to the power of m divided by a to the power of n is equal to a to the power of m minus n. A to the power of m, everything over a to the power of n is equal to a to the power of m minus n. A to the power of 0 is 1. Open curve bracket, capital A, to the power of small n, close curve bracket, to power of small n, is equals to a to the power of mn. A to the power of 1 over n is equal to the nth root of a. A to the power of m over n is equals to the nth root of a to the power of m, also the same as open bracket, curve bracket, nth root a, close curve bracket, to the power of m. A to the power of minus n is equal to 1 over a to the power of n. A to the power of minus 1 over n is equal to 1 over nth root of a. A to the power of minus m over n is equal to 1 over nth root of a to the power of m. A to the power of minus m over n is also equal to 1 over open curve bracket nth root of a, close curve bracket, to the power of m. Beautiful, wonderful. Congratulations and celebrations. Why so? Because we have gotten 100%. Wunderbar. Wonderful in the German language. Yeah. Thank you so very much. It is that very easy, you know. So, whoops, they say I need to capture this stuff first. Good. Look here. Yeah, .png. I can send this to students. Say I'm creating courses. Okay, even create PDF, this .png, and then JPEG files I can send over as bonuses. Alright, always remember always. This is 100 what? %. And these are the formulas for indices. Okay? Go. No need to revise already. Not necessary. Why do you need to revise? No need. No need to revise. We already know how to obtain these formulae. So here you are. One more time for the record or for the record or for the record. Yeah, wonderful. If you want to celebrate the success, whoops, daisy. Celebrate the success. Go one bigger. Let's celebrate. Congratulations and celebrations. Da da dee da dee da dee da dee da da rum. Param pam pam pam. Da da dee dum dum. Param pam 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 param param pam pam pam. Congratulations and celebrations. Wow, no joke. Do you think there's something behind there or nothing there? Yes? No? Yes. There you see. Right. So, okay, one more time. All the best, yeah? We've gotten 100%. With this, we solve all problems, any problem, anywhere and everywhere, any place and every place, whatever, okay? Laws of indices will be used to solve whatever is related to indices. 100%. Nothing less. We don't want anything less than that. Yeah. Very good. We're happy. So even the weakest of the weakest, now you're already the top gun, you know. But don't be proud, yeah? Don't be proud. 100%. Thank God.